So we're going to figure out now what happens to the negative electrode or the cathode during an electrolysis. And especially when we talk about the medium that we're electrolyting, if there's such a word, is an aqueous solution. That means it's a salt dissolved in water. And when that happens, you have two competing ions going into the electrode. And so at the cathode or the negative electrode, you have electrons all jumbled up and packed up into the cathode or the negative electrode. And the positive ions are going to get, that are near the electrode, are going to get attracted to it. And here you have two types of positive ions. One from the salt, and the other from the water solution. Okay? So let's use sodium chloride as an example. Alright? So in sodium chloride, it's Na. The positive ion is going to be Na. And then the water is going to have H+. So H+ and Na is going to get attracted to the negative electrode or the cathode. And when that happens, these two are going to compete to form to become neutral elements. And what's going to become the neutral element? Well, we have to refer to our reactivity, metal reactivity chart, and you learned this in KS3 and you'll learn it again in the next term. The chemical reactivity chart. If the chemical is more, element is more, or the ion is more reactive, it's going to want to stay in the solution because it's more stable that way. If it becomes a neutral element, it's going to be very reactive. So the reactive metal is going to prefer to stay as ions in the solution because it's more stable that way. So for sodium chloride, you can see the sodium is up here and hydrogen is all the way down here. Hydrogen is all the way down here. And when we compare the two, well, sodium is very reactive, so it's going to want to stay in the solution. And so what happens is that the hydrogen ions is going to become the neutral element. So the hydrogen ions plus another hydrogen ions, when you deposit electrons onto it, is going to form H2. And what you're going to see is bubbles forming around the cathode or the negative electrode, and hydrogen gas is going to escape. And that's exactly what's happening. And so if I put another example, such as copper, copper is some sort of sulfate solution, what it's going to have is that copper is going to compete with hydrogen. Hydrogen is just above the copper in the reactivity series, so copper is preferred, right? Because hydrogen now is more stable in solution compared to copper. So copper is going to get deposited around the electrode, all right? And you're going to do more research about which electrodes we're going to use, but that's outside the point of view. So copper is going to get attracted to the electrode, and copper metal is going to get form deposits around the electrode. So that's it for what's happening at the other side.